Humans are impressed by speed for a simple reason. On Earth, speed changes your life immediately. Go fast enough and cities shrink, oceans become a short flight, continents feel like neighborhoods. But space doesn't care about our instincts. In space, fast can be a comforting story we tell ourselves until we do the arithmetic. Start with a thought experiment. Imagine the most extreme pace we've ever given a machine. So fast, it would lap the Earth in minutes if it skimmed the surface. It sounds like the doorway to the stars. Yet, when you aim that same velocity at the nearest star, the destination barely moves closer in any human sense. The gap between stars isn't big, it's a different category of distance, like trying to measure an ocean with a teaspoon. That's the first shock. Interstellar travel fails not because we lack passion, but because the universe is scaled in a way our bodies never evolved to grasp. Your lifetime is the ruler you secretly carry in your pocket. Everything you dream of doing out there must fit inside it. Inside a few decades of breath, sleep, hunger, and heartbeat. Space travel becomes a question of biology as much as engineering. Now picture the edge most people imagine. The point where the solar system ends. It feels like there should be a border, a final signpost, a clean line you can cross and declare victory. But the solar system is less like a fenced yard and more like a family whose relatives keep living farther and farther out. Beyond the planets is a long fade of frozen debris, comets, and ancient leftovers, still loosely loyal to the sun's gravity. Reaching those distant outskirts is already far beyond what a typical lifetime could comfortably cover, with anything resembling our current propulsion. Even leaving the sun's extended influence is not a quick sprint. It's a multi-century marathon. And that leads to the second shock. Even when a probe leaves the solar system, it may only be leaving one kind of influence while remaining trapped in another. Headlines love a clean ending. Physics almost never provides one. Our rockets, for all their elegance, share an ancient idea. Throw something backward to go forward. It works beautifully for reaching orbit, the moon, even the outer planets, when time and fuel budgets are finite, but still human-scaled. But for the stars, the same method becomes a kind of mathematical punishment. Every extra slice of speed demands more propellant, and more propellant increases your mass, which then demands even more propellant. The equation doesn't negotiate, it escalates. So you try to cheat. You steal momentum from planets with gravity assists. You trade patience for velocity, weaving through the solar system like a pickpocket slipping coins from giant moving bodies. It helps. It's clever. It is also not a bridge to interstellar travel within one human life. It's a ladder that reaches a little higher, on a wall that rises far beyond the clouds. You try another angle. Engines that sip propellant efficiently, pushing gently for months or years. That's good for reshaping orbits and reaching distant worlds with graceful precision. But the thrust is so tiny that faster becomes a slow philosophy rather than a sharp breakthrough. At this point, the honest question forms. If a lifetime is roughly 80 years, how far can a human truly go? Not in a movie. Not in a press release, in reality. If we stay inside the old toolbox, chemical fire, incremental efficiency, a few gravitational slingshots, then the answer is humbling. Your life, spent entirely in motion, would still be mostly a life spent near home. You could roam the solar system. You could cross astonishing numbers of miles, but the stars would remain where they always were, close enough to see, far too far to touch. And then comes the twist, the part that makes space travel feel less like a locked door and more like a puzzle with hidden hinges, because there is a way to travel farther in a lifetime without breaking any universal speed limit. To find it, we have to let go of something even more familiar than rockets, We have to let go of the idea that time is the same for everyone. There is a reason space travel feels impossible even before we talk about engines. We are trapped by an assumption so deep that we rarely notice it. The belief that time flows the same for everyone, everywhere. That a year is a universal unit. That your clock and the universe's clock are in quiet agreement. They are not. The moment you move fast enough, that agreement collapses. This is not philosophy. It is measurement. At everyday speeds, the effect is invisible. A car, a plane, even the fastest rocket humanity has ever launched. All of them move so slowly compared to the ultimate speed limit of the universe that time behaves as if nothing strange is happening. Clocks stay in sync. Aging feels fair. Cause and effect feel intuitive. But push velocity high enough, and time begins to stretch. A clock in motion ticks more slowly than one left behind. Not metaphorically, literally. Every physical process, chemical reactions, biological aging, the firing of neurons, runs at a reduced rate compared to the outside world. To the traveler, nothing feels different. Their heart beats normally. Their thoughts arrive on schedule. The strangeness only appears when they compare notes with someone who stayed home. This effect is called time dilation, and it has been tested so many times that it no longer counts as a prediction. Atomic clocks flown on aircraft return slightly out of sync. Satellites must correct for it constantly, or GPS would drift into uselessness within hours. The universe enforces it quietly, relentlessly, without exception. And this is where space travel stops being about distance and starts being about perspective. Because distance doesn't shrink for the universe, it shrinks for you. Imagine accelerating to a speed where time aboard your ship slows to half its normal rate compared to Earth. 1 year for you becomes 2 years for everyone else. Travel faster, and the imbalance grows. At extreme speeds, decades can pass outside while you experience only a few calm years. The barrier that once looked like a wall becomes something else entirely. Not a wall, but a toll. The universe doesn't forbid you from crossing great distances. It simply demands payment in time that you will never personally experience. You can go far, but you must accept that the world you leave behind will race ahead without you. This changes the question completely. How far can humans travel in one lifetime? No longer means how far can we go before our bodies fail. It means how far can the universe age while we barely do? At modest fractions of light speed, the effect is subtle. Time slows, but not enough to matter psychologically. You gain months, maybe a few years. It's interesting, but not transformative. But push closer to the cosmic speed limit, and something extraordinary happens. Years collapse. Distances that once required thousands of years of waiting can be crossed, while your hair only begins to gray. A journey that would outlive civilizations becomes, to you, a long but survivable expedition. This is the loophole hidden inside the laws of physics. The speed of light still cannot be exceeded. From the universe's point of view, everything remains painfully slow. Stars remain far apart. Galaxies remain isolated. But from the traveler's frame of reference, the universe compresses itself along the direction of motion. Space shortens. Time stretches outward behind you. The faster you go, the less distance you personally experience. This is not science fiction. It is the same mathematics that governs every particle accelerator on Earth. The same rules that keep satellites honest and clocks obedient. Yet the loophole comes with a cost so severe that it feels almost cruel. To exploit time dilation, you must move at speeds that demand absurd amounts of energy. Not slightly more energy, not 10 times more, exponentially more. As velocity rises, Adding even a tiny fraction closer to light speed requires energy on a scale that dwarfs nations, planets, even stars. The universe allows the trick, but it charges interest so extreme that it borders on the prohibitive. And there is a second cost, quieter but more personal. You do not get to bring your time with you. Everyone you leave behind ages faster. Every culture evolves without you. Every language drifts. Every relationship stretches thin, then snaps. When you return, if you return, you arrive not as a traveler, but as a visitor from the past. Time dilation does not let you outrun time. It lets you choose whose time you experience. Once time stops being absolute, the universe stops looking impossibly large. It still is large, but no longer untouchable. Now the question becomes concrete. If a human lived an ordinary lifetime aboard a spacecraft, how much of the cosmos could pass beneath them? Not in theory, not with magic, but using the exact rules the universe already follows. Start modestly. Imagine a traveler moving fast enough that time aboard the ship slows noticeably. Fast, but not extreme. The outside universe ages a little faster than the traveler does. The gain is measurable but small. Over decades, it might buy you a few extra years. Helpful, but not revolutionary. This is not where the universe reveals its secret. The transformation begins when velocity climbs into truly relativistic territory, when speed becomes a significant fraction of light itself. At those velocities, the relationship between distance and time breaks in a way our intuition was never meant to handle. From Earth's perspective, the traveler still crawls. Light years remain light years. The clock on the wall keeps turning at its usual pace, but aboard the ship, something else is happening. Distance contracts, not metaphorically. Physically, the space ahead of the traveler shortens. The universe along the direction of motion compresses. Stars that were once impossibly far apart draw closer, not because they moved, but because space itself changed shape relative to the traveler. This is the part that feels like cheating. A journey that would require centuries for the universe can unfold in decades for the person inside the ship. Increase the speed further, and decades shrink to years. Push closer still to light speed, and entire stellar neighborhoods slip by during what feels like a single chapter of a life. At sufficiently extreme velocities, the math becomes unsettling. A lifetime measured in 50 or 60 subjective years can span hundreds, then thousands, then tens of thousands of light years. Not by breaking the cosmic speed limit, but by letting time do the work for you. At these speeds, a human could cross regions of space containing millions of stars. They could leave the familiar spiral arm of their birth and enter regions of the galaxy forever hidden from Earth's telescopes by dust and distance. Star-forming nebulae. Ancient stellar populations, environments shaped by physics so violent or so old that no human eye has ever seen them directly. And still, the traveler would simply feel alive. They would sleep, wake, eat, think, age normally. The universe outside would just be running faster. Push the velocity higher, and the scale escalates again. A single lifetime could carry someone across most of the galaxy, from one edge to the other, from regions where stars are young and metal-rich, to places where ancient suns burn dimly in silence. From the traveler's perspective, the galaxy becomes traversable. But the universe does not give gifts without taking something in return. Because while the traveler gains distance, they lose era. Every year they live, the universe lives many. Civilizations rise and fall behind them. Languages evolve beyond recognition. Entire histories unfold, while the traveler barely notices the passing of time. If return is even possible. They do not come home. They arrive in the future, a future so distant that their departure has become legend or archaeology, a future where the planet they left may still exist, but everything that made it familiar has been erased by time's steady work. Relativistic travel turns space into something conquerable, but turns time into a one-way door. And there is another catch, deeper and more final. Even if technology were perfect, even if energy were unlimited, there are places no traveler can ever reach. Not because of speed, but because the universe itself is changing shape. Space is expanding, not gently, not slowly. It is accelerating. Some regions of the cosmos are already being carried away faster than any traveler could chase them, even at near light speed. Those destinations exist. Their light reaches us, but they are receding into permanent inaccessibility. The universe is not just vast. It is slipping away. There is a final limit that speed cannot defeat, not because engines fail, not because bodies age, but because the universe itself refuses to wait. Space is not a static stage where events unfold. It stretches, it grows, and on the largest scales, it grows faster with time. Galaxies are not simply far apart. They are being carried away from one another by the expansion of space itself, like islands drifting apart on an ever-widening sea. At first, this seems irrelevant. After all, if you can move fast enough, shouldn't you be able to chase anything? The answer is no, because beyond a certain distance, the expansion of space outruns every possible journey. This boundary is not a wall you crash into. There is no sudden stop. Instead, there is a horizon. Quiet, mathematical, absolute. A distance beyond which no traveler departing today can ever arrive, no matter how long they live or how close to light speed they move. It is called the cosmic event horizon. Everything beyond it is already lost to us. Light emitted from those regions today will never reach Earth. Not because it is too slow, but because the space it must cross is expanding faster than light can traverse it. Each second, the destination recedes more than the photon can advance. A spacecraft fares no better. You could accelerate forever, pouring energy into motion, watching time outside your ship race ahead. Yet the gap would never close. The universe itself would stretch faster than you could cross it. This is not speculation. It is the same mathematics that governs the expansion of the cosmos and has been confirmed by decades of observation. The universe is accelerating outward, driven by a mysterious pressure embedded in space itself, and that acceleration draws a line through reality. On our side of that line, exploration is difficult but possible. Beyond it, exploration is forbidden. What makes this limit unsettling is that it is shrinking. As cosmic expansion accelerates, regions that are reachable today will become unreachable in the far future. The accessible universe is slowly closing in on itself. Galaxies we can see now will fade, redshift, and vanish beyond the horizon. Not destroyed, not gone, but permanently disconnected. For a traveler, this creates a strange urgency. You could depart tomorrow at near-light speed toward a distant galaxy and still fail. Not because you were too slow, but because the destination slipped beyond reach while you were on the way. Even perfect propulsion cannot outrun an expanding universe. And yet, within this shrinking domain lies a staggering truth. Inside the cosmic horizon, the distances are still immense. A human lifetime, when combined with extreme time dilation, could cross not just star systems, but large fractions of a galaxy. With sufficient velocity, it could span tens of thousands of light years. Enough to traverse the Milky Way from edge to edge. Enough to see regions of the universe that will never be visible from Earth. For the traveler, this would feel like a long life spent moving forward. decades of thought, memory, and experience. For the universe, it would be an instant followed by silence. The farther you go, the more one-way the journey becomes. Return is not forbidden by physics, but it is poisoned by time. A round trip costs you not distance, but history. You can come back to the same coordinates, but not to the same world. A journey of a few hundred light years returns you to a civilization transformed. A journey across the galaxy returns you to a species that may no longer exist. A journey between galaxies erases every meaningful connection you ever had. Relativistic travel does not let you explore without consequence. It asks a question instead. How much of your past are you willing to abandon for distance? So how far could a human actually travel in one lifetime? The honest answer is unsettling, not because it is small, but because it is conditional. If you demand return, familiarity, and continuity, if you want to leave and come back to a world that still knows your name, then the universe is conservative. Your reach is measured in nearby stars, perhaps a few hundred light years at the extreme. Even with extraordinary speed, the cost of coming home is paid in centuries of Earth's time. You return as a relic, not a resident. But if you are willing to let go of return, the scale changes completely. Once you accept that time will not follow you, distance loses its tyranny. A single human life, properly accelerated, could span vast regions of the galaxy. Not in fantasy, not by violating physics, but by embracing it fully. The universe allows this. It does not resist. It simply keeps its own clock. With sufficient velocity, a lifetime could cross spiral arms, star-forming regions, ancient stellar halos. It could move from the crowded heart of a galaxy to its quiet outskirts. It could witness environments shaped by forces so different from our own that Earth becomes a footnote by comparison. Push closer to the limits, and the galaxy itself becomes crossable. In principle, one human life could traverse the Milky Way, not quickly by the universe's reckoning, but briefly by the travelers. Decades of lived experience measured against tens of thousands of years passing elsewhere. The traveler would not feel rushed. They would simply feel detached from history. Beyond that, the universe grows less forgiving. Intergalactic travel is allowed by the equations, but it is a one-way exile. You can reach another galaxy within a lifetime only by surrendering your era forever. The moment you arrive, your origin civilization has vanished into deep time. You become a witness without an audience, a discoverer whose discoveries can never return home. And beyond a certain distance, even that freedom ends. The expanding universe draws a final boundary. Not a wall, not a catastrophe, just a limit. There are places whose light we can see, but whose shores we can never reach. No engine, no lifespan, no clever use of time dilation can change that. The universe has already decided. This is the deepest truth hidden inside the question. The universe is not built to stop you from traveling far. It is built to make you choose what kind of traveler you are. Do you value return or reach? Connection or discovery? Belonging or distance? Physics does not answer these questions for us. It merely lays out the consequences with perfect honesty. A human lifetime is short, but it is not small. Given the right velocity, it can span distances that once seemed reserved for gods and myths. It can cross the galaxy. It can touch the deep structure of the cosmos. It can see places that no telescope will ever resolve clearly from Earth. But every step outward is also a step forward in time. You do not just travel through space. You travel away from your moment in history. And perhaps that is the final lesson. The universe has not placed us in a prison. It has placed us at a crossroads. It offers vast distances in exchange for time, and time in exchange for distance. It offers exploration, but never without cost. The stars are not impossibly far. They are simply expensive, measured not in fuel or money, but in years you will never share with those you leave behind. How far could a human travel in one lifetime? As far as they are willing to let the universe move on without them. The cosmos allows it. The equations permit it. The only remaining question is whether we will ever decide the price is worth paying.